Hey guys, welcome to day 17 of the Leetcode challenge. And today's question is minimum path sum. Right. First of all, if you haven't subscribed to our channel, please do because we are posting daily discussions on these Leetcode challenges that is ongoing for the 30 days. Let's dive into today's problem. So given a m cross n grid filled with non-negative numbers, find a path from top left to bottom right, which means from here to here, which minimizes the sum of all numbers along its path. You can only move either down or right in any point of time. So basically, given a grid, you basically need to find some path along this grid which minimizes the sum of the numbers, right? So you can think of how can I reach the last cell, right? I can reach it from here or reach it from here. Now, if I can find the minimum sum of these two cells, say A and B, then basically I can find the minimum sum for the last cell C, which can be num at C, right, which is the number actually present at C, plus minimum of A or B, right? Because I cannot reach this cell from anywhere else other than A and B, and I have to take minimum of path to A and path to B, right? Recursively, I can call so if I call calculate C, I have to call recursively calculate A and calculate B, right? Here C, if I represent C by I comma J, which means ith cell, ith row and jth column, then I would have to, now A becomes I minus 1 comma J and B becomes I comma J minus 1, right? So I comma J depends on these two values. Now, if we have to recursively call these, then at some point of time, let's say this cell X would be counted many times. It's same as how we calculate the Fibonacci, right? So there also we use a lot of recursion, n minus 1 and n minus 2, and ultimately we optimize by doing a memoization, right? Or you call it dynamic programming also, right? So this is what we intend to do here. We intend to store the solutions we already calculate here. So we have to store the solutions for each I comma j cell so that we don't have to calculate again and again. Right. So how do we do that? I'll just rub this board and construct my calculated array. Suppose this is the original grid you are given. Right. Now this is my min path till grid. This is my computation I'm storing in a separate 2D grid, right? So this will be order n into m space solution. We can also get to a space solution where we only take order m space. We will do that later. I will tell you how to do that, but let's look at the first solution right now. Okay, so this is the minimum path till array which will store the already computed values. Some people also label it as the DP array, right? So how we'll construct this is, so this each cell of this represents the minimum path to reach that particular cell, from 0, 0, right? So eventually, if this is the min path, then our answer would become min path till n minus 1, m minus 1, right? So this will be our final answer which we can return, right? Now, as we have previously seen, the cell depends on upper cell value and the left cell value, right? So how we can construct this grid is, first of all, we know that in the first row, in the 0th row, the only way to come to a cell is from the left cell, right? So we will construct this row first, right? And similarly, for the 0th column, we have to construct the 0th column. And for this, basically, we just need to do something like this: dp of 0, which means for 0th array, 0th row. Here I'm calling dp as the min path till. What we need to do is dp of 0 of j minus 1, right? Which means the previous column's value plus grid of 0 of j, right? This is the only way you can accomplish this. There is no other part. This is the only part. So you have to construct this. Uh, Now for any value within the within this smaller within this remaining min path step, right? What we'll do is for I comma j, you need to add the number itself, right? I j, right? Plus this is what we have seen earlier, minimum of a and b, which means minimum of dp of I minus 1 j and dp of I and j minus 1, right? So for any particular cell here, you take if this is the minimum or either this is minimum. So use either of these two cells, right? And you construct this whole dp uh, grid, and your answer becomes min path till the last array, right? So or the dp of the last cell, right? Okay, let's try to look at this in code, how we code this. So first of all, I'm just putting n and m into the length of the grids as n and m. This comes in handy if you want to iterate multiple times. Now we declare a min path till array. This is basically our DP array, right? And we need to assign it for I in. I'm just initializing it. Right. For consistency, I will replace I and j to be okay. So I've initialized it to n rows cross m columns, right? And each have 0 value, right? Now we first need to first calculate 0th row value. Calculate 0th column value. We can do this in one loop also, in a two nested for loop. We will just have more if conditions in the iteration. Fill in rest of the area, right? So for 0, 0, the number would be same as what is on the grid on 0th index, right? Now let's fill the 0th row for I in range. One to m. So GP of I, so GP of 0th row, and each j becomes GP of 0th row, its previous column plus the number, actual number, right? Now same goes for the 0th column, I minus 1 to 0 plus grid of I of 0. Okay. Now we just need to iterate from range 1 to n for j in range 1 to m. Okay, let's fill out the rest of the values. Okay, I have written TP and min path till array. So this is confusing. I should have just used either one of those. Okay. Okay, great. Okay, let's try to run this code. Okay, let's try to submit this code now. Okay, accepted. Now, as I was telling you that currently we are using space complexity. Our space complexity is equals to n into m. We are using this men path till array, 2D array, right? So we can get away with just using order m space. How? Because what we are doing is we are going row by row, right? So in this loop, we are assigning or calculating a minimum path value row by row. So we don't need to store the minimum path values for rows that are beyond the last row itself. So we just need to look up one row before us to get the values, right? We don't need the value of I minus 2 or I minus 3 rows, right? So what we'll do is we'll just use order m space, which means number of columns, right? So we'll remove this and we are just using order m columns. Now we need to initialize the value of the uh, min. So the first values to be the min path values of the 0th row, right? So this holds true. First calculate 0th row. This is exactly as we would have done. It's just that now we don't have 2D array, instead of we have 1D array here, right? Now we don't need to calculate 0th column value, right? But instead, what we need to do is, if we delete this, we need to actually fill the 0th column value for each of the row, right? So we'll do this here actually in this loop itself. So minimum path till 0th row equals to till of 0 plus grid of I of 0, right? So this basically stores the previous row's 0th column value, right? And we are adding this path value to the current row's 0th column number, right? And hence we are storing this for the current row here, right? So we don't need to do this. Okay, great. Now how does our loop changes here? So a loop changes. So for each, so we are already processing the ith row, so we don't need this. And we don't need the row number here, and we don't need the row number here, right? And what will just return is the last value of the array. Okay, let's try to submit this code. Okay, accepted. Right. So thanks for watching the video, guys. If you have any questions or comments about this video, please comment below and subscribe to our channel because we are posting daily videos. And yeah, thanks for watching again. Bye bye.